Welcome to qnawire.
If a coffee pot begins cooling in a room at time 0, and it's given by the function t of t, we want to find a function t of t, which would be the inverse function that takes the temperature t as an input and outputs the time in t. So let's think of this as in terms of, I'm going to think of this in terms of y and x temporarily. So I'll do it. Actually, we won't. We'll use capital and lowercase t, but we're going to interchange. So this would be a lowercase t equals 102 e to the negative 0.02 capital T plus 7d8 to find the inverse. We interchange the variables, solve, because we're going to basically undo everything that the original function is doing. So we'll subtract 78 to both sides. Then we'll divide 102 to both sides. Then we're going to take the natural log of both sides to get rid of the exponential base e. And then we're going to divide by negative 0.02. And then we'll be equal to t, capital T. So our function would be t of t would be the natural log of, we'll interchange them back now, t minus 78 over 102 divided by negative 0.02. Using the function, how long will it take for a pot of coffee to reach 80 degrees? That would be t of 80, and so that would be the natural log of 80 minus 78. Just 2 over 102 divided by negative 0.02. We get 196. I'll go to the nearest tenth. 196.6 minutes. If we graphed the function in part A, the function would have a vertical asymptote. It's a natural log function, and so the vertical asymptote would be the x-axis, or the y-axis, or x equals 0. What would it mean in respect to the coffee pot? That would be that would be before the shift, though. But because of this shift to the right 78, that vertical asymptote would actually not be at 0. That would be its parent function, but it would be at 78. So what would it mean? It would mean that the temperature of the coffee could not go less than or else they would approach 78 degrees but not go less than. That would be the temperature of the room.